include only the human influences, you would overestimate what happened over the last 50 years in some degree. But if you include everything together, you count quite well. Particularly about carbon dioxide. If you just look at carbon dioxide and methane, that's what I should have said. When I talk about human influences, you would overestimate. But if you take into account the particles as well, then you can actually match the record pretty well. So basically the changes we've seen over the last 50 years can only be explained by human-driven changes. The oceans, sea levels have risen about 7 to 8 inches since 1900. It's been increasing, accelerating the rate such that the current rate of sea level rise is the highest it's been in at least 2,800 years, probably much longer. We're seeing nuisance flooding issues already in many places around the country, particularly in the East Coast, but also in California, where when you get high tides, you're likely to have flooding in the streets. It used to not happen in the same way it's happening now. Over this century, we can expect another 1 to 4 feet of sea level rise, but we can't say for sure that it won't be as high as 8 feet. And that's because of what's happening in West Antarctica. Lots of concerns about whether basically the ice in West Antarctica could just fall into the ocean if the base of ice in the ocean there actually falls apart. Unfortunately, the evidence is suggesting that that's going to happen, but we're jury's still out on that. It's not just about sea level rise, though. An extra carbon in the atmosphere, 25%, is ending up in the oceans. It's acidifying the oceans. It's making the oceans less basic. That's having an impact on shellfish already. And how that will feed through the food chain is still unclear. Some recent analysis suggests some life forms are not affected by the increased acidification, but many others are. And how will that affect us is still unknown. And I've already mentioned the changing ocean circulation, particularly the Atlantic. Now, impacts are already apparent in every region of the United States, throughout most parts of the world, and in important sectors including health, water, agriculture, energy, etc. So I'm going to focus in on those now. We also know for the first time this assessment looked at the economic impact. And analyses are still very incomplete. I think they're going to increase by a bit, actually, for new analysis in the future. Right now, they suggest a 3 to 10% increase in GDP, 3 to 10% effect on GDP by the end of this century. It may sound like much, but that would be a big effect, just due to one factor on the United States economy. So let's look at food, water, energy nexus, and I'm going to particularly kind of turn that around and start by looking at water, because I think it's the driver of a lot of the changes, particularly in the Southwest. These three systems, as we all well know, are strongly interconnected, impacted by both climate and non-climate stressors. And so the question is here, what are the climate stressors and what role do they play? These influences affect these systems individually, as well as dynamics among these sectors. So we'll look at them first a little bit individually. And then the multi-sector perspective is necessary to understand the risk and develop response strategies that enhance resilience across multiple systems. Managing risk is the way we need to think about our future. Let's look at water first of all. Water for people and nature in the Southwest has declined during droughts, due in part to climate change. Intensive drought and occasional large floods, combined with critical water demands from a growing population, maturing infrastructure, and groundwater depletion, suggest the need for flexible water management techniques that address changing risks over time, balancing declining supplies with greater demands. And if we look at the Colorado River Basin, as discussed in this report, we found that the projected water demand is likely to outpace the